Alrighty, we're going to go over the Unit 12 review, which is on function families. So the first question says to determine which family each representation belongs to. So you have to know the shape of the graphs and what the equations look like. So for this first one, I see that it's starting at 0, 0, and it's the dolphin jumping out of the water. So that's going to be the radical. It's actually a square root graph, so if you really want to be specific, you can write square root. Okay. Next one is a parabola or a U-shaped graph, which means that its parent graph is quadratic, which means it'd be like y equals x squared. This one, there's two parts to the graph, and there's the only one that has two parts, which is the rational one. We just did that last chapter. And then finally, this one is going up from left to right. Linear would be a line, absolute value would be a V, polynomial would not look like that shape. Quadratic we already did, root we already did, log looks like an R, and we already did rational. That leaves us with an exponential, and more specifically, this is an exponential growth. You don't need to know that. Okay, but now we get these equations, and how are we going to know which one's which? So you have these bars right there, so that is definitely going to be an absolute value. And then the next one, you have x to the third power, which means that we would call this a polynomial because it's a power higher than 2, and we have names for graphs that are a power of 1 or a power of 2. Next, we get to this guy. The x is in the exponent, making this an exponential. It's the only one where the x will be in the exponent. And then we go to our last one, where we're looking at this guy right here. More specifically, this is x to the first power, so the highest power of x is 1, so that makes that linear. Okay, you have all that in your notebook, 12.1. The next little piece asks us to use a table, an equation, and a graph to find some of these values. So let's make sure we are good to go. So this one says g of -2, and this right here tells us that the graph is the g graph. So this is the x value right here, -2. So we're going to go to -2 on the x-axis, which is here. We're going to connect it to that point right there. So that's -2, 3. So when the input is -2, the output is 3, and then we're going to add that to our next function, which is the f function, and it's f of -1. Again, knowing that the x value is -1, we go to the f function, and -1 will give us an output of 9, so that equals 12. The next one is number 10, and it says h of 1. So let's be clear, though, it actually says 2. We're not going to change anything about that, so we're just going to bring it down. And then it says h of 1. So here's the h function. So what we're going to do is do h of 1, which equals 2 times 1 minus 1, which is 2 minus 1, which equals 1. So then we're going to say, hey, when the input is 1, the output is also 1, so that's kind of cool. And then we're going to do f of 3. So we're going to go back to our f function and see that when the input is 3, the output is -3. So make sure you put that in parentheses so that you get that double negative. So that's 2 plus 3, which equals 5. The next one says f of 1. So we're going to go to 1, and the output is 3. So we're going to put equals 3 over, and the next one is g of 3. So when we do g of 3, that's going to be the graph over here. So we need to go to an x value of 3, and we see when the x value is 3, the graph has an output of 4, so that's just going to be 3 over 4. For number 12, we're going to copy down the 1/3 because we can't do anything with that just yet. And then we're going to go back to that f function when x is 5, because it says f of 5, the output is -9, minus h of 0. So we're back to that h function, which is right there. So we need to plug in 0. So if I do h of 0, that's 2 times 0 minus 1. 2 times 0 is just 0, so that's going to be minus -1. And then we have to do with the math on this. Just a friendly reminder, when you're multiplying fractions, no big problem. Top times top over bottom times bottom. So 1 times 9 is -9. Over 3 times 1 is 3. That becomes +1, and -9 over 3 is -3 plus 1, which equals -2. Okay, moving on to the next little bit that will be on your test. It says describe the transformation. So let's take a look at our parent graph. They give it to us right there. It's 4 to the x. So we need to look at everything that's different comparing 4 to the x with this. So we see that we have a -1 there. So the transformation for that guy is just going to be right 1 because it's in with the x. So it's grouped up in that parenthesis. And remember that the y doesn't lie, but if it's in with the x, your x does. So the y doesn't lie, but your x does. So it looks like the -1 would mean left 1 because that's where our negatives are since it's a minus. But it's always the opposite with the x value. Next little thing we have is we see the change here that we have a negative in front, and then we have a -1 that's not in with the x. So the negative out in front means we're going to reflect over the x-axis, and the one that's not grouped up with the x is just going to be down 1, because that makes sense that when you're with the y value, you go down 1. For this next one, again, comparing 4 to the x up here with this graph, they added a +5 and a +9. So how is that going to change my graph? That means I'm going to go left 5 because normally x is a horizontal direction. So any number that's grouped with the x means that it's going to be horizontal, left or right. Because it says +5, we think +5, which is to the right. But because of the way math works, it's actually going to be the opposite and to the left. So the y value of +9, the y doesn't lie, but your x does. So we're going to go left 9, or left 5 and up 9. Okay, now we have another new parent graph. This time our parent graph is actually x cubed. Right, cube root of x. And so then we need to highlight what changes. So first we see here we have a negative, but that negative is grouped in with the x. So that's actually reflect over the y-axis. Okay, for the next one, we see that we have a +2, but it's under the radical with x. So your y doesn't lie. Well, this isn't a y, this is an x, but your x does. So +2, again, we think it would go right 2, but it's actually going to do the opposite and go left 2. For this last one right here, we see that -6, which is not under the radical, so it's not with x. So this is not going to lie to us. It's just going to go down 6. For the next problem, this actually wants you to recognize first what the function family is and then notate the different transformations that have happened. So this graph right here, the parent graph, because it is the spaghetti noodle, is y equals x cubed. So in order to figure out how it changed, first we're going to look at this right here, which is the parent graph. The blue one is the parent graph. And how did that change? Well, you can see our graph was going from down to up, and now it's going up from down. So there's some sort of reflection. And in this particular case, it could be either x or a y-axis reflection, so I'm just going to put reflect over x-axis, and that means that there will be a negative in front. And then the other piece of this is that you can see that this point actually moved up 2. So what would that look like in our equation? So we would have negative x to the third power, and then that plus 2 would be up 2. I do want to let you know that this is also an acceptable solution to have the negative in front and then up 2. They're the same thing. So in this particular situation, it could either be a reflection over the x-axis or y-axis. It's just a really unique property of cubic graphs. Okay, let's take a look at this next graph. First of all, you want to identify your parent graph, and that is clearly a V-shaped graph, which means that it stemmed from the absolute value of x. So the blue graph, again, is your parent graph. So see this point right here? How did this move? So that point is now here, and it went right 6 and down 2. So how would we incorporate that into our new equation? I should actually write this as g of x instead of y, but it's fine. Right 6 is going to be minus 6 because the x's are always opposite. So right is positive, but we're going to put a minus because it's the opposite. And then down 2, the y don't lie, so you can just put down 2 as minus 2. Okay, moving on up to the next one. We have this. This looks like an exponential graph. We're going to have to figure out what the parent equation is. So we can do that by just looking at these points. So let me see. I got that point right there is a nice point. That point is 2, 4. And this point right here is 1, 2. This point is 0, 1. This point is 0, 1/2. So what I'm seeing is that these are going up by 2. So the parent graph is going to be y equals 2 to the x. And then I'm going to see how that parent graph in blue shifted. So I'm going to circle in on this point, which isn't at 0, 0, but it's the y-intercept, so it's 0, 1. So first of all, this graph was going this way, but it's flipped over the y-axis. So actually flip isn't a math term, so I'm going to delete that and put reflect over y-axis. So after you've done the reflection, then you can see this point moved all the way down to this point. So it's down 1, 2, 3, 4, 5, down 5. So what would that look like in equation? G of x equals 2 to the negative x, because that's a reflection in the y-axis. That always goes in with the x, and then down 5 is minus 5. Okay, let's flip it over. And on this particular one, we're not going to worry about this little table that's been written here. So I'm just going to go ahead and cross that out. And what I want you guys to do is do what we've done in all the other lessons and go, okay, I have to graph using transformations from the parent graph. So I need to identify the parent graph. Well, I just have the transformed graph and there's an extra plus 1. So the parent graph on this situation is actually y equals 2 to the x. So if I make a table for that, which is really easy to do because all I have to do is plug in numbers. So 2 squared equals 4. 2 to the first power equals 2. So hopefully you see that what I'm doing right here is plugging in all these x values and then simplifying. So I'm going to do that for all of them. I get 2 to the 0 power is 1. 2 to the negative 1 is really 1 over 2. And 2 to the negative 2 is really 1 over 2 squared, which is 1 over 4. So if I take those parent points, which I'm going to put in this pinkish color, I have here, and then I have here, 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 and here. So there's my parent points. And then I just need to recognize that that right there means I'm going to move all of my parent points left 1 because the plus 1 is in with the x and the y doesn't lie, but your x does. So it's the opposite of what you would think. So plus 1 you would think would mean right 1, but it actually means left 1. So we're going to move all these points left 1. And then because it's an exponential function family, it's going to go up like that. So same thing for number 22. We're going to first recognize that there's a negative in front and then there's a plus 3. So if those were not there, this would tell us that our parent graph, and also you can kind of just look at it, is quadratic, or y equals x squared, and that the transformations are reflect over the x-axis because the y is in front, and then go up 3 because that 3 isn't in with the x. It would be in parentheses if it was in with the x. So what the heck will this look like? No prob, Bob. I just make a table for my parent graph and then plug these numbers in. -2 squared would be -2 times -2, which would be 4. And then -1 times -1 is +1. 0 times 0 is 0. 1 times 1 is 1. And 2 times 2 is 4. So then I'm going to graph all those parent points. So I have -2, 4, -1, 1, 0, 0, 1, 1, and then 2, 4. You don't have to have that memorized. You just need to be able to identify your parent graph and then go from there. And we already said that what we're going to do is we're going to reflect over the x-axis. So let's take care of that first. I'm going to put those points in green. So reflecting over the x-axis, here's the x-axis right here. So what I'm going to do is start with this point right here, and it's 4 away above the x-axis, so reflection would be 4 down. This one's 1 away, so it would be 1. This one's on, so it would just stay the same. This one's 1 away, so it would be 1 below. These are 4 above, so it would be 4 below. Okay, so that takes care of the reflect over the x-axis part. And the last part that I'm going to take care of is just moving all those green points up 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Feel free to use colors on your test. It helps make us be aware of what we're actually trying to do. Okay? So those two questions were from 12.3 and 12.2, but now we get into the last little part about functions, which the last 3 questions are about the lesson on 12.4. So let's keep in mind that this first one right here means g of x minus f of x. So if you can get your mind not to think of that and just go straight to that, it'll do you a better service. And then what you're going to do is take that g of x function, which is 2x squared, and then you're going to subtract it from that f of x function. And because f of x has 1, 2 terms, you need to put that in parentheses, otherwise you're going to get it wrong. And then from there, what we're going to do is distribute that, so we end up with 2x squared minus x minus 1. Okay, so that's that problem right there. Let's see, 24 says g of x, and this is a time symbol, so we're going to do g of x, which is 2x squared. Doesn't hurt to always use multiplication, times, and this one is f of x. That's our first function, which is x plus 1. And we know when you're multiplying one term times 2 terms, you use the rainbow method, and you get 2x cubed plus 2x squared. For the last one, we're going to use h of f of x. So h of x is right here. It is this guy right here. So that comes from here. And what they're saying is that we want you to input into the x part of h of x the f of x function. And f of x on the left side is just f of x. But if that doesn't work out for you, you can always just look at the right side, because that's what an equal sign means, and plug in this part. So really what we're doing is h of x plus 1, which means that we're taking x plus 1 and putting it in there, because that's the new input for h of x. So it's going to look like negative, because I'm copying that. And x is not my input anymore. My new input is this guy. So I'm going to put x plus 1 and then plus 5. So that is the answer for that guy. Moving up to the top here, it says determine the inverse of each function. So just to be clear, to find the inverse, give it a try. Switch the x and the y. Now solve for y. You're almost done. Don't forget the negative one. So we have this equation, and all we're going to do is first switch x and y. So you can see that in pink. The next step is to solve for this y, and we just have to do reverse math to do that. So what I'm going to do is subtract 14 from both sides. And when I do that, I get x minus 14, because these are not like terms, so I can't group them together. Then I see an equal sign, then 1/2 y, and then those guys cancel out. Next, I need to undo this 1/2, and the easiest thing to do is to multiply both sides by 2. Again, every time you're multiplying or anything, you have two terms here, so you have to put it in parentheses. So these 2's cancel, and I get 2 times x minus 14 equals 1y. Well, we all know this 1 doesn't need to be there. And then we can simplify this, although it's not really simplifying, it's just rewriting it in standard form as 2x minus 28. So if you look down here, you have that right here. And I'll be really clear, technically, this should say y inverse on that. The next one says y equals x minus 1 squared. So step 1, to find the inverse, give it a try. Switch the x and the y. Okay, so this is that part of that. Now it says solve for y. So if I'm solving for y, that's the part that I'm looking to get by itself. So in order to undo the square, I need to square root both sides. Okay, and then that leaves me with the square root of x equals the square root undoes the square, y minus 1. So now, again, I'm still trying to get that y by itself, which is right there, but there is a minus 1, so I'm going to add 1 to both sides. These are not like terms right there, so I need to write it as the square root of x plus 1, with them being next to each other, equals y. And then for our final step, we always change it to an inverse. So I was just about to write it as f inverse, but then I noticed right here that this didn't start with f inverse, it started with a y. So really my notation should be y inverse equals the square root of x plus 1. If you want to write the y on the right side, that's fine. You won't get any points taken off because it's still correct. All right, for the last two problems, you're given a graph and you have to write the inverse. So just a friendly reminder, if you're given a table or a graph, what you need to be able to do is switch x and y. So what you're going to want to do is look at your graph and pick some key points. So 1, 2, 3, 4, 5. So I'm just looking at the places where the graph intersects the plane or the grid at nice clean spots. So for me, my parent points would be -2, -5, and then I have -1, -4, and -1, -6, and then I have one here at 2, -3, and 2, -5. So then what I'm going to do for my for my inverse function is I'm just going to switch all those values. Except for I'm just noticing right now that I made a mistake on that last one that I just did. No problem. That is actually right here, which is 2, -7. So going back to this right here, I'm switching the X and Y's. And then I'm going to plot those points. So just to clear this up real quick, I'm going to delete what I've put on here and then just plot the purple points so you can see it more clearly. So I have -5, -2, -4, -1, -6, -1, -3 and 2, and then also -7 and 2. So this is the inverse graph right there. Make a table, switch X and Y. For the next one, same exact thing. I'm going to identify some key points on here. That one looks good. That one looks good. That one looks good. I usually recommend you pick 5 unless you can't pick 5, but generally speaking, 5 is always the way to go. So I have this first point is -5, -3, then -4, -1. That was, and then this one is -3, +1, -2, +3, and -1, +5. And then for the inverse, just switch X and Y. So again, just clearing off what I already had on there to make it easier for you to see. -3, -5, -1, -4, 1, -3, 2, 3, -2, and then 5, -1. And that is what the inverse graph would look like. And that is it for the review.